You step outside on a clear night. You look up, and the moon is gone. In its place, filling a portion of the sky so enormous it barely seems real, hangs something else entirely, a planet, banded, striped in amber and cream and rust, a storm system wider than Earth rotating visibly, slowly, across its face. A pale ring of trapped debris circling its equator in a thin, glittering line. Jupiter. Not a point of light the way Jupiter appears from Earth tonight, not the bright, steady dot you might mistake for a star if you do not know where to look. This version of Jupiter is close. Where the moon sits at 384,000 kilometers from Earth, this Jupiter is there, right there. And the sky is no longer the sky you have ever known. It would be the most beautiful thing you had ever seen. It would also be the last thing you ever saw, because placing Jupiter where the moon is would not create a spectacular view for curious astronomers. It would end the world. Not slowly, not over centuries of gradual change. Within hours, within days, in a cascade of destruction so complete and so final that nothing of the world we know, not our civilization, not our ecosystems, not even the shape of our continents, would survive. This is not science fiction. This is physics. And following the physics, step by step, from the moment Jupiter arrives in the moon's orbit to the final inevitable conclusion, tells one of the most dramatic stories in the entire catalog of cosmic thought experiments. Let us begin. And let us begin with the thing that would kill us first. Not fire, not impact, not radiation. The tides. The moon controls our tides. This is something most people know in a general way. The gravitational pull of the moon on Earth's oceans, slightly stronger on the side of Earth closest to the moon, slightly weaker on the far side, creates the familiar rhythm of high tide and low tide. Twice a day, reliably, predictably. A gentle, ancient, geological heartbeat that has shaped coastlines and ecosystems and the behavior of every creature that has ever lived near an ocean. The moon is 384,000 kilometers from Earth. The moon has a mass of approximately 7.3 times 10 to the 22nd power kilograms. Jupiter is also 384,000 kilometers from Earth in this scenario. Jupiter has a mass of approximately 1.9 times 10 to the 27th power kilograms. Jupiter is roughly 317 times more massive than Earth itself. It is more than 25,000 times more massive than our moon. Let that number be present in your mind. 25,000 times more massive. Now consider what that does to the tides. The tidal force a body exerts on Earth scales with the mass of that body and inversely with the cube of the distance. Because distance is the same, both the moon and our hypothetical Jupiter are at 384,000 kilometers, only the mass difference matters. The tidal force exerted by Jupiter at the moon's distance would be approximately 25,000 times stronger than the tidal force exerted by our moon. Our moon raises ocean tides of roughly 1 to 2 meters in the open ocean. In funnel-shaped bays and coastal geometries, this can be amplified to 10 or 15 meters at places like the Bay of Fundy. Multiply that by 25,000. In the open ocean, tidal bulges would rise to heights measured in kilometers, not centimeters, not meters. Kilometers. Walls of water rising from every ocean basin simultaneously, drawn toward the nearest point facing Jupiter, and again on the opposite side of Earth in a counter-tidal bulge. Tidal waves of incomprehensible scale sweeping across entire ocean basins, driven not by storms or earthquakes, but by the simple, relentless gravitational mathematics of a planet 317 times Earth's mass sitting where the moon used to be. Every coastal region on Earth, every city, every town, every piece of infrastructure built within reach of the tidal surge would be overwhelmed within hours of Jupiter's arrival. But the ocean tides are not the most destructive consequence, because tidal forces do not only act on liquids, they act on solids too.
The solid body of Earth itself, the rock and mantle and crust that feels so permanent beneath your feet, would experience tidal deformation under Jupiter's gravitational influence. Earth's crust, flexing and straining under forces 25,000 times greater than what the Moon exerts, would begin to crack. Fault lines that have been locked in geological equilibrium for millions of years would slip. Every tectonic boundary on Earth would become seismically active simultaneously. Every volcano, every fault, every geological weakness on the planet energized by a tidal force our planet was never designed to withstand. The earthquake and volcanic activity triggered in the first hours after Jupiter's arrival would dwarf anything in recorded history. And we have not yet talked about the atmosphere, or the radiation, or what Jupiter's magnetic field would do to everything in its vicinity. The tidal destruction would be only the beginning.
Jupiter is not just a massive ball of gas. It is one of the most powerful radiation environments in the solar system. Jupiter's magnetic field is roughly 20,000 times stronger than Earth's. It extends outward from the planet for millions of kilometers in every direction. A vast magnetosphere that traps charged particles, accelerates them to near light speeds, and forms intense radiation belts around the planet. These radiation belts are lethal. NASA's Juno spacecraft, designed specifically to orbit Jupiter and study it in close proximity, required specialized radiation shielding to survive its mission. Even with that shielding, the spacecraft accumulated significant radiation damage over the course of its extended mission. If Jupiter were placed at the distance of the Moon, its magnetosphere, that vast, charged, radiating bubble, would not simply pass around Earth, it would engulf it. Earth's own magnetosphere, our natural radiation shield, the invisible force field that deflects the solar wind and protects the surface from the majority of cosmic and solar radiation, would be overwhelmed, compressed, pushed inward, potentially stripped away in the regions most directly exposed to Jupiter's field. Without our magnetosphere, the surface of Earth would be bathed in radiation levels that would kill unshielded living organisms within days. But it gets worse. Jupiter's magnetosphere rotates with the planet. Jupiter rotates fast. A full Jovian day is only about 10 hours. As Jupiter's magnetic field swept past Earth every 10 hours, it would interact with Earth's own magnetic field in violent, dynamic ways. Magnetic reconnection events, explosive releases of magnetic energy, would energize Earth's ionosphere and produce auroras on a global scale. The night side of Earth would light up with curtains of plasma-generated light so intense they would be visible in broad daylight. The electromagnetic interference generated by Jupiter's magnetic influence on Earth's ionosphere would disable every unshielded electronic device on the planet. Satellites in orbit would be fried, power grids would fail, communication systems would collapse. The technological infrastructure of global civilization, every computer, every server, every network device, would be rendered non-functional. And above all of this, in the sky where the Moon used to be, Jupiter would hang. Enormous, banded, rotating visibly, its great storm, the Great Red Spot, a hurricane 3 times the width of Earth, drifting slowly across its face in a display simultaneously magnificent and horrifying. The moons of Jupiter would orbit visibly in real time. Io would be a point of volcanic light, Europa a glinting crescent, Ganymede and Callisto tracing their own paths around their host planet in the sky above a dying world. It would be the most extraordinary thing any human eye would ever witness. No human eye would witness it for long. Let us step back from the immediate, violent consequences and consider the larger picture. The scenario requires placing Jupiter, an object 317 times Earth's mass, at 384,000 kilometers from our planet. The immediate physical effects are catastrophic, as we have described. But the gravitational dynamics of this arrangement are themselves fatal on a longer timescale. Earth and Jupiter, at that distance, would not simply sit in stable coexistence. The gravitational interaction between them would be enormously complex and almost certainly unstable. Jupiter's gravity, at 384,000 kilometers, would exert a tidal force on Earth that would not merely deform our planet's surface, it would begin to affect Earth's orbit around the Sun. The Sun holds Earth in its orbital path through a gravitational relationship carefully maintained over 4.5 billion years. The arrival of a body 317 times Earth's mass in close proximity would immediately begin perturbing that relationship. Earth's orbit would become unstable, elliptical in ways it has not been for billions of years, eccentric, unpredictable. Over months and years, if the scenario somehow persisted, Earth could be flung into an orbit that took it significantly closer to the Sun, cooking it, or significantly farther away, freezing it, or ejected from the solar system entirely, becoming a rogue planet drifting in the dark between the stars. None of these outcomes are survivable for complex life. The other planets of the solar system would not be unaffected either. Jupiter's gravitational influence moved from its current position in the outer solar system to the inner solar system where Earth orbits would fundamentally destabilize the orbits of Mars, Venus, Mercury, and potentially the asteroid belt. The carefully balanced gravitational architecture that has kept the inner solar system stable for billions of years would be destroyed within decades or centuries. Our solar system, as we know it, would cease to exist. And here's one final irony worth contemplating. Jupiter, in its real position in the outer solar system, is believed by many scientists to act as a gravitational shield for the inner planets. Its enormous mass diverts comets and asteroids from the inner solar system, capturing some into its own orbit and flinging others entirely out of the solar system. Without Jupiter in its real position, Earth would likely face a far higher rate of large impacts than it currently does. The planet that would destroy us if placed at the Moon's distance is also, from far away, one of the reasons Earth has been habitable long enough for complex life to evolve. Jupiter is our guardian and our destroyer simultaneously, protecting us from its proper distance, annihilating us if brought too close. The universe, it turns out, is very particular about where you put things. This will never happen. Jupiter will never replace the Moon. The gravitational mechanics of our solar system have no mechanism to move a planet from the outer solar system to the inner one and park it at the distance of the Moon. Even in the most violent, chaotic scenarios of early solar system dynamics, nothing like this has ever occurred. The thought experiment was always fiction. But the best thought experiments are not about their fictional premise, they're about what the premise reveals. And this one reveals something extraordinary about the world that actually exists. The Moon is the right size. Not in any designed or intentional sense, not because someone chose these dimensions, but in the rigorous, measurable, scientifically verifiable sense that the Moon's actual mass and actual distance produce tidal forces that life on Earth has evolved to work with, has been shaped by, and in some ways depends on. Our Moon is large enough to stabilize Earth's axial tilt. Without it, Earth's axis would wobble chaotically over tens of thousands of years, producing climate swings so extreme that the development of complex life might have been impossible. The Moon's gravitational stabilization of our axial tilt is one of the reasons Earth has had relatively consistent climate conditions over geological scales. Our Moon is large enough to drive the tidal rhythm that has shaped every coastal and oceanic ecosystem on Earth. Some biologists believe the tidal cycles generated by the Moon may have played a direct role in the transition of early life from ocean to land, the rhythmic exposure and submersion of coastal environments creating conditions that encouraged amphibious adaptation. Our Moon is small enough that its tidal forces, while significant, do not tear the crust apart or generate runaway tectonic catastrophe. The Moon is, in this precise technical sense, calibrated for life. Not perfectly, there is no perfect, but within the range of conditions that allowed 4 billion years of biological evolution to occur and ultimately produce a species capable of asking questions about gas giants replacing natural satellites.
And beyond the moon, the entire architecture of our solar system. Jupiter at its proper distance, Saturn at its proper distance, the asteroid belt where it is. The orbits arranged with the particular gravitational balance that has produced 4.5 billion years of relative stability in the inner solar system. Each piece in its place, each at the right distance. The universe did not have to arrange things this way. Most of it did not. Most solar systems are more chaotic, more hostile, less finely tuned for the slow, patient emergence of complexity in life. We happen to end up in one of the quieter neighborhoods. And the best way to appreciate that, the clearest, most visceral way to feel the weight of how fortunate that is to imagine what the neighborhood would look like if someone moved the furniture. Jupiter where the moon is, the sky on fire, the oceans risen to the mountains, the world ended before morning. And none of it real, none of it happening, nothing but a thought experiment in the mind of a species that lives on a modest, well-positioned planet under a modest, well-behaved moon, in a solar system that, against considerable odds, turned out to be just right. Look up tonight. Be grateful for the small light in the sky, and for the large one that stayed where it belongs.